Hello, everyone. Welcome to our webinar this morning. We're just going to wait a couple more seconds here to let a few more people join. My name is Caroline Coons. I'm with Wavefront, and I just want to take care of a couple of quick housekeeping items before we get the presentation and demo going. So first of all, please note that we will be recording this webinar, and we will make that available to everyone tomorrow. We'll send it out in an email to everyone who's registered and attended. So you will have that available for on-demand viewing. Also, another item to note is after the presentation and the demo, we're going to open up for Q&A at the end. And so to participate in the Q&A, there is a chat box. If you type a message in there, it'll send the message to our panelists. And then we will be able to go through those questions at the end. And so with that, I'm going to hand things off to Nate, who will be our presenter today, and he can introduce himself.
Hi, everybody. I'm Nate Warden. I'm a staff systems engineer with Wavefront team at VMware. And I'm going to talk to you today a bit about Wavefront and what it is, what it does, and how it can fit in with your systems, your applications, your containers, and so forth. So first, we're going to roll through about half a dozen slides, and then I'm going to go into a product demonstration to really show you how to dig into Wavefront, what you're looking at in terms of data, how to create alerts, and so on. So Wavefront in and of itself is a time series-based data analytics and monitoring platform. And so what you get from Wavefront is real-time results at a massive scale. So if you're talking about the ways you used to do monitoring in the past, you'll see that as we go today, we'll ingest at least 1 million data points per second, and then that's actionable. And since we do that in real time, you'll find that the scale is unparalleled. A quick aside is if you thought of like time series based data in terms of, say, a flight data recorder or maybe a taxi cab service in a major city, if somebody goes, hey, what time did this taxi leave point A and get to point B, and what route did they take, and you want to be able to analyze all the steps in real time and also figure out if there's an anomaly at some point along the way, that's where Wavefront fits in. Given our time series-based nature, you'll find that our ability to give you the results back from even the most complex of queries will happen in a second or so. So let's get into our deck here a little bit. So what we have in the modern world of DevOps is the particular point of view here is that you'll have this increasing software dynamism and rise of containers and microservices. And so there's a trade-off though. Back in the day when we would install services, or maybe we'd even use the cloud to deploy systems, what you would find is that you would have a certain set of metrics you would capture, and that would scale naturally. But in the case of containers in particular, or microservices, you'll find that the more you enable code pushes rather than quarterly for a quarterly release or weekly or yearly or whatever, you'll find that faster code pushes means that you have increased complexity in terms of the data you're looking at and what it means. So let's say that in the ways you used to monitor things in the past, you had 100 metrics, and maybe this is even for something that was virtualized. Now with containers and microservices, you'll have thousands of metrics, and you're trying to figure out what to do with them. And you need to be able to have this data in real time. You have to do things at a high speed, given the sheer volume of data that you'd be putting into a platform like Wavefront. So in other words, your older tooling is not going to keep up with these scales and changes, and even if things fail over. Secondarily, the concept of continuous delivery in DevOps have been adopted into larger enterprises. So in the past, where you might have a separate ops team and a separate network team and a separate system team or teams, you're going to have potentially a DevOps group that's going to be responsible for deploying everything, whether it be a system, whether it be a container, whether it be a microservice. And the concept I've mentioned about pushing code to production many times per day, that means you have to be able to deliver and continuously monitor that code. So if something goes wrong, you understand why. And the demo will really focus in on some of these aspects. And so finally, even though DevOps is considered a mainstream pursuit, the tools that an engineering and ops team will use are still fragmented, and this slows down troubleshooting and key services availability. And so with Wavefront, it doesn't really matter the tool you're using, all the metrics are there, and you'll be able to do something with them. So this is where Wavefront really comes in. We're Saas-based. Like I mentioned earlier, we do monitoring, we do analytics. And DevOps and developers teams at various enterprises that run cloud-native apps, and some customers are such as Box and Lyft and Intuit and Workday, will use us to monitor the performance of cloud applications that have reached a scale of at least 1 million points per second. And that's the case, for example, of Box. We're going to collect and analyze metrics from really any application, and it could be on a public cloud, it could be in a private cloud, it could be AWS, it could be a container, it could be a microservice, it could be cloud infrastructure, and even any kind of data that you put into it, so we can analyze it, we will do that. And then, once that data gets into our Wavefront time series databases, multiple teams, whether it be a DevOps team or an ops team or a set of developers, et cetera, you can apply powerful and flexible analytics in the form of the Wavefront query language. So our key differentiators are really that our scale is massive. Okay, we can DevOps and developers teams can use Wavefront to monitor the performance of their cloud services and distributed applications, and this is done at an unprecedented scale. So if we're talking about at least 1 million PPS, we do that. Many of our competitors do not. That way, if you have all this data, this massive amount of data, and you're getting things back in real time, you can troubleshoot faster, you can do proactive alerting, and you can then detect leading indicators of these anomalies. In terms of speed, we give DevOps and developer teams, or really anyone, instant visibility across all the cloud services. Also, we're self-service. So what this means is when Wavefront comes into your organization, your adoption isn't just one group or another. It can be your entire organization. And this allows you the self-service approach. And in that sense, people are empowered to be able to look at what's in Wavefront, are there issues, and they can collaborate with other groups, even if they're completely different silos, completely different managers. Everyone's looking at that at the first pane of glass, and I'll get into that as we go. And so we're typically adopted at leading SaaS enterprises where cloud services are lifeline, and it helps everyone make these analytics-driven business decisions. They're synchronized with cloud services, and cloud and code delivery helps everyone move faster. So the key differentiators here is that Wavefront allows you to apply advanced metrics and query-driven analytics. We have over 100 mathematical functions where you can work with your metrics data, and I'll be calling those out once we reach the demo section. This allows you to troubleshoot issues faster and also give accuracy in what you're reporting. Again, massive scale and high availability, and this really exceeds what all the open source tools are able to produce today. We're going to talk about customizable dashboards, or dashboards generally, and that helps people really focus their attention and take ownership for code that's in production right now. Dashboards are simply exported with a single click. And then intelligent alerting and proactive monitoring help detect leading indicators, and this is done really quickly, and it helps you zero in on anomalies. And we'll definitely walk through that as part of the demo today, and I'll call it out when we get there. And what we're going to be looking at are shapes, and that will become clear once we start looking at charts inside of the dashboards. And these shapes can exist whether we're talking about any point in time or any condition that you define. So to get data into Wavefront, there are several ways to do this. You can ingest metrics data using one or more collector agents and the Wavefront proxy. So an agent such as Telegraph or cAdvisor, that allows you to collect the metrics such as capacity and usage from your systems, and then these get output into Wavefront by Wavefront proxy. The proxy works with your Wavefront server to ensure security and end-to-end flow control. Your application can send metrics directly to a proxy without an agent. We support code instrumentation, and we'll use libraries such as Drop Wizard or others to send specific application metrics into Wavefront. You can also pull data directly from AWS using APIs, CloudWatch, and CloudTrail. And then, of course, we create metrics from logs. This could happen in the case of, say, a web server such as an Nginx or an Apache. So this is the last slide for now. I'm going to talk about Wavefront integrations, and that's really our starting point for how we fit into your environment. Let me check the chat here really quickly. I see that we have a couple questions, and what's going on here? Yes, so the answer with InfluxDB really comes down to support, and it comes down to scale. We store basically any kind of metric that you will put into us, and the agent is going to be host-based. It can also be hypervisor-based in the longer term. At the end of the day, though, as far as agents go, they'll be deployed on a system. And in the case of a container, as I mentioned with Docker, it'll be cAdvisor. In the case of PKS or Kubernetes, it's going to be Heapster. But let me get into the demo, and then I'll come back to the questions as we go. Okay, so as I mentioned earlier, Wavefront is that first pane of glass, or the first line of defense in understanding all of your metrics and understanding if there's an anomaly, what to do with it. Before you can use Wavefront, that is integrate with a container or a system or an application, and it doesn't matter if your data is on-premise, if it's in the cloud, if you have a custom application, or any combination of sources, we offer a proxy behind the scenes. And this allows you to send data, and we accept several different formats. We're going to focus on integrations here for a couple minutes, and these integrations can be command line install, or in the cases of known cloud providers like your AWS's, your GCP, Azure, et cetera, there are more full cloud integrations. And in the case of PKS and Kubernetes, you would deploy using Heapster to get the metrics into Wavefront. In addition to that as well, I mean, I'd mentioned the command line-based integrations. We do support Puppet. We have some integration tooling coming out very shortly, and we support Ansible and so on, and we can talk about it later on during Q&A. In the meantime, though, let's take a peek at Amazon, and let's take a look at all these various web service integrations. So we're going to integrate these through CloudWatch. So as you can see here, we're under this setup area, and in terms of setting up Amazon integration, it's really a snap. What you're going to do is, and this takes a few short minutes, is you're going to set up a read-only account, and then you're pretty much off to the races from there. That will get all your data from Amazon. In terms of our dashboards here, if we go into our dashboards tab, you'll see a whole bunch of different available dashboards. So we'll look at EC2 for the moment. At the end of the day, we're that first line of defense, and we're trying to reduce the number of tooling that you're using to get similar metrics or dissimilar metrics from similar or dissimilar areas of your business. And the idea is, instead of having a million different types of tooling, why not just have one? And Wavefront really leverages that concept. And so what you get is that if you're looking at a network issue, you don't have to go to a specific network tool to see if there's a networking problem. Or you don't have to go to the systems team if there's a system problem. Or if there's a memory problem, you don't have to go to the applications group to see who's responsible for JVMs or so forth. So by giving an experience like this is an out-of-the-box dashboard. We understand that at the end of the day, a business is concerned about how EC2 is performing. So while we provide these dashboards out of the box, it doesn't mean that you can't create custom dashboards. You are still able to really use any of these indicators based on the incoming metrics and create custom dashboards from those. But at the end of the day, whether we're talking about one of our pre-distributed dashboards or we're talking about a custom dashboard, Wavefront is a one-stop shop. You get that first line of defense, and that also enables you to consolidate your tooling. So here you see an example of what a dashboard might look like when you pull all things together. This is a custom dashboard. In fact, this is what Wavefront uses to monitor Wavefront, because because as I mentioned, we're SaaS. So in behind the scenes, we'll deploy Wavefront. We have to understand if Wavefront is working after deployment. And so we need very specific things. So you'll see such things as cloud load average, et cetera, latency, request latencies. And I want to key in on one of these things specifically. So you'll see here that we're looking at an availability zone of AZ1, and we have two specific zones, but let's key on AZ1 because something's happened. So you can see here that at some point, our CPU load average has gone way down. And at some point, the latency has gone way up. And as you work through these charts on the dashboard, you'll see that at some point, our byte sent has really dropped off the radar screen. We went from like 35, 40K to 0. Obviously, that's not normal. And so one of the things Wavefront really brings to you is that, let's say that you have an operations team or someone who's just watching charts during an event, whether it be a code deployment, whether it be something else. What you get with Wavefront is that to the naked eye, certain things are highly visible. And what we see here are two things. One, we see, as I pointed out, our bytes per second have dropped off the chart. But secondarily, we have this blue section right here, which talks about a code deployment. And so while there are other metrics available, such as memory used, et cetera, requests, top 5 CPU percentage, at the end of the day, we already know there's a code deployment. So it really comes down to the semantic here. Was this outage expected as the result of a code deployment, or was this outage something that we had not expected and therefore we have to go deeper? But at the end of the day, being able to quickly identify problems across the stack is super powerful and is straightforward when you're looking at a level plane of data across all of these items. So let's move on to how to actually navigate the Wavefront dashboard itself. So here we see a cluster overview. And one of the things that, and this is common to every dashboard, one of the things you're looking at is any of these sections you can roll up, okay? And if you want to just scroll down, you can scroll, all the way through. But let's unroll these and take a look at what we're looking at. So if you didn't want to roll things up, you could click through any of these sections at the top of the screen. And if I clicked on CPU, it would take me to the CPU part of the chart. The other thing that's really interesting here is that, Wavefront really has this concept of signals and noise. So if I was looking at request latencies, to my naked eye at least, this looks like we have some things that are super high latency. We have other things that are not that high latency. And so as we dig through these charts here, and we look at things like various entries, various memory used, et cetera, what you can do is attract these signals through the noise, and you can pin various lines from these charts. And you can see here, I'll just pin a couple for the sake of discussion. it's a control click, or in the case of a Mac, it's a command click, and you'll see that the sources below have been collected. It tells you what you're looking at, but you also see that all the charts were automatically updated. If you're done with looking at these various sources, you can simply unpin these sources and your charts will go back to the state where they started. But let's say we've found some kind of condition here. Let's say that we determined that we wanted to look at memory use between 12:30 and say 12:45 on a given day. We can easily zoom into the single chart, and then we can simply say, okay, I want to draw all of my charts given the same point in time that I've selected, and simply you click that overcrossing arrow and you'll see that in a second or so, all my charts update with that same point in time. But here's what's really interesting. When I had mentioned collaboration earlier, what you get with Wavefront is that what we've just drawn is something you can share with other teams. So let's say I'm a networking guy and I say, yeah, right around 12:45, something here is an anomaly. I can simply click this link icon and it'll give me this link, which I can mail to other people. So if I go in and I say, yeah, so let's share this with our ops team and say, hey, at this point in time, there was an issue. When you click through that link as an ops person, or maybe another DevOps person, or maybe a manager even, you can see that all of our charts are drawn in exactly that same state at the exact point in time. So this really exemplifies what we're talking about in terms of single or first pane of glass and first line of defense, where everyone is looking at the same data, everyone's on the same page right out of the gate. So now I want to showcase how we can solve some problems by way of a dashboard. So we're going to show you in this example from start to finish when you're trying to understand some kind of operational problem. So in this case, you see the top two charts, and these are relevant to this demonstration right here. The top left chart is a KPI transactions per second. We're monitoring literally actual transactions that our application can serve. And this is our gold standard as to whether we are healthy or not. So we can see pretty noticeably from this chart that we're falling off in this case. And also, given this red shaded area, we can see that an alert is fired. And so if we mouse over this red button here, there we are, we'll see that the host that's impacted is app 5 apparently, and then it's getting an alert for aggregation transaction rates are too low. So the first thing though, before we even get into diagnosing what's happened, is understanding its impact as to what's happened. So we're going to take a look at how many customers are impacted, because this is a common thing. We know app 5 is there, but we know that in the case of applications being distributed, maybe many customers have data shared across different app servers. So we're going to take a look at the customers first, for this to load. And very clearly, what you'll see is that if we mouse over this, you'll see that during this degraded state, all customers have been impacted by this decreasing transactions per second. So it looks like we understand the scope of what the problem is here, but now let's take a look by app server. Straw, and then very clearly the purple line here and the alert all correspond to, or all strongly suggest that we have a problem with the app server number 5. So now let's take a quick peek at this correlation chart here, because what we want to do is that we understand that on app 5 server, there's been an issue or set of issues, and then we see all this noise by way of the correlation chart. So you'll see many metrics here, like a disk space used, a request latency, a disk bytes read, etc. And this represents all the data an engineer is going to want to sift through or need to sift through when trying to understand what's going on. Now, I worked in IT for a long time, And I can say for certain that oftentimes I knew our infrastructure well enough, or I knew what we're doing in the cloud well enough, where I could make an educated guess. I could be like, yep, I know exactly what's going on with App Server 5. I know things well enough where I don't need to necessarily use Wavefront just because I guess, but it isn't always going to be you who's on call. And so other people are going to have to know what the likely indicators of these problems are, and they're going to have to be able to sift through them quickly, because if you have a major customer outage, it's something you're going to have to deal with. So we know that the transaction count has failed here. What we can do is move over to App Server 5 under our application servers, and we can then say, yeah, let's do a correlation with the transaction count here. And sure enough, this correlation on App Server 5, its transaction count is directly related to what we're seeing in the transactions per second. But when we correlate that transaction count to all of the metrics we had seen here under correlations before, you'll notice that there's been an interesting change. Certainly, while the transaction count has gone off the rails, you see this gray line here where our memory free has gone way down. You'll see the orange line, which is that our log errors have increased and that our garbage collection count has increased. So given these deltas in what was happening performance-wise, application performance-wise on application server number 5, we have now something actionable to work on. And so what we can do then is, from this point in time, you can do further examination with Splunk and so on and so forth. And there are other external data sources that you can integrate with Wavefront to take a look really at log messages and other items. The other thing is alerting, though, and that's really the most important aspect. And that everything we do from an alerting perspective is based on a query language. And so we alert on anything that we visualize, and that would include what you're seeing here in this correlation chart. So for example, if we wanted to alert any time that our transaction rate was falling below a certain threshold, you can say, show me the correlation between failed transactions and performance. And then that's the alert you want to get. And you can be delivered literally the screen by way of your alerting system at this exact drawing. So you wouldn't need to come back, as I mentioned earlier with this link icon, for example. You won't have to come back and say, okay, well, so I got an alert, but then you have to start over and drill through the UI. It's literally right there for you to look at. So let's talk about alerting a little bit. So the gist of Wavefront alerting is that we will do something with a metric, usually based on some kind of threshold, and we're going to integrate with really anything. It can be an email alert that goes out. You can use your PagerDuty key, or you can use a webhook. So whether you're talking about Nagios, whether you're talking about Splunk, or whether you're talking about something else, so long as we have a webhook to integrate with, everything will go well. But let's take a look at some cases where we have metrics and we're trying to understand what we're seeing in these metrics. So in this case, I want to take a look at request latency. And this is when you're creating an alert, like I mentioned earlier, when we're taking a look at that KPI discovery. When you create this alert, it's drawing a signal from this noise. It's drawing a needle from a haystack, if you will, where you have a little magnet to pull it out. And so let's say that this organization, your organization, has got some kind of threshold constant of, say, 240 milliseconds. Anything that or higher would trigger an alert. So you can simply say, yeah, you know, I have all this noise of this request latency, but I want to simply say, fine, let's make it 240. And you'll see that there's some kind of anomaly here. That's great. If you go on and say, yeah, you know, let's look back 12 hours, you'll see that there are a bunch of anomalies. And you can do the same thing for 1 day and 8 day, and we'll get there momentarily. But let's say you want to apply some kind of function to this data. And so in this case, we're going to apply a moving window. So I'm going to go through this list of functions here, and it doesn't matter the function, whether it be maverage, whether it be median, etc. You'll see that we give you the use pattern or the usage of how you actually use this message. And so what we have is, the moving average computes the moving average of each data line separately over a shifting time window. So if you were to set this threshold, and I'll go back to this, this query wizard in a moment to show you where you'd set it. If you set it for, say, 60 minutes, it will return the moving average over the last hour for each source emitting that metric. And so it goes on to describe what it is. But in this case, I want to apply a moving maximum. And so you'll notice some interesting things have happened here. I'm going to go back out to a 2-hour window just so we have very clear drawing of what's happening in this chart. But you can see a couple of interesting things. So you see that we crossed that threshold of 240 once. We crossed it again here. We crossed it again here. And not only did we cross it, you'll see that there was an alert fired. There was an alert fired at 8:45. There was an alert fired at 9:30. There was an alert fired at 10. So if I'm the person who's on the literal pager duty here, it's going to drive me crazy. So this is where having some kind of historical view of what's happening with an alert is helpful in determining on how to scale it. So let's take a look at the one day moving maximum average of alerts that were created. And you can see there are a whole bunch. So this is where you have a decision point. You want to say, is 240 a hard stop? Or do we go for something like a 250 or a 260? Is this expected behavior, or is it merely the way these metrics are being reflected? Because you can see here, even on this one-day moving average of our request latencies, you're still getting a bunch of alerts. They're happening every few hours. And the reason I'm mentioning scaling the alerts is because there's a temptation when you have a bunch of alerts coming in, if you're that person who's on call, if something becomes kind of organizational knowledge that is faulty, people will start ignoring it. And that's obviously not what you want. So let's take a look at 260 for comparison. And so what we see here on this one-day window is that basically all the churn that was happening during this length of time, there's duration that we had seen under 12 hours has basically gone away. We're getting some peaks here in August. We're getting some peaks here, at various times throughout the day, but generally speaking, things are quiet. So your determination then is, are we going to move the maximum? Are we going to increase the threshold? I mean, that's really for your organization to decide. But certainly, if you look at things historically, which we're able to do with our 8-day window here, you can see that a whole bunch of alerts would have fired, and it's really the criteria for which you would determine if an alert is, if a metric is valid based on the alert you're creating. So that's everything I have today from a demo standpoint. Let me go over to the chat window to see if folks have any questions. Okay, let's talk generally. I was given a question about, can I use Log Insight within PKS? What do I need from a network connectivity's perspective? Let's talk about PKS a little bit. Let's talk about our integration. I've been one of the people who's been responsible from the Wavefront end of things with working with PKS and deploying code. So going back to the integration screen here, we'll go into PKS, or it's actually Pivotal Container Service. And the way this is going to be set up is what you're going to do, and we'll walk through this sec here, is this is going to work essentially the same way as Kubernetes. So you're going to do your Wavefront integration by entering this account information, but at the end of the day, you're going to be deploying a Wavefront proxy, and here are the steps for that. So what you see here is you have a proxy YAML file, so you're going to be deploying a Wavefront proxy by way of Kubernetes or PKS. You're going to have a specific Wavefront token that's going to be unique to you. This is where your URL is going to be. So in the case of an environment, it's probably going to be longboard.wavefront.com rather than our demo environment. You're going to then use kube control for any of these steps. So whether it be proxy.yaml, whether it be a proxy service, where we're defining our ports for this, you're going to use kube control for everything. And the same goes really for deploying Heapster, where you'll see Heapsters here, and we're defining various things like, what is our replication controller, make a service account for Heapster, and so on and so forth. And then you're going to do kube control create with your Heapster YAML file. So this will do everything you need to do in getting your PKS stuff integrated with Wavefront. Your code itself is going to then point at Heapster, which in and of itself then is pointing at the Wavefront proxy. In fact, let me just highlight that for you. So you can see under Heapster, when you define the Wavefront proxy up top here, it's given a name, an app and a name of Wavefront-proxy, and it's going to use the Wavefront-proxy default service cluster local on port 2878, and that's literally as easy as it is. So let's talk about, do I get the entire cluster info or per node? Yes, you're getting the entire cluster information. What's going to happen? We'll take a look at Kubernetes metrics just for example. But what you see here in terms of metrics, and you can filter based on names. So if you want to take a look at cluster-related metrics, you'll see that there are various cluster-related items here. But certainly, if we take a look at a Kubernetes dashboard, for example, just for the sake of framing this, given the question, you'll see that we definitely do break the nodes out as well, but we'll talk about clusters. So if you're trying to figure out, for example, a CPU rate usage by node, you can simply mouse through this as we had before, command click it, and on a dashboard, and be able to understand what's happening on a per node basis as well. I'll have to check on the question about protected healthcare information and BAAT's Wavefront. The short answer is if we can ingest metrics, then it doesn't really matter what the input source is. You can certainly send other platforms data into actually, let me read the question. Is a primary use case container environment? We have SolarWinds and AppDynamics and Splunk already. Can we send the data into Wavefront? So the answer is yeah. So long as you're able to send the metrics in a format we can consume, we certainly can. In terms of Splunk in and of itself, I usually see customers going the other way, where they'll want to say, okay, well, I have this metric in Wavefront. We know this is our first pane. This is our first line of defense, but then I'll look at Splunk for something. Yeah, if we can consume it, then we can certainly do something with it. And going back to integrations for a moment here, you'll see there are a number of areas here where we'll integrate. So if we don't have it, it can certainly be created. So also, the one thing I want to point out with Wavefront is that the starting point is really being able to do a free trial. Before I joined the Wavefront team at VMware, they actually said, okay, why don't you learn how to do some things in Wavefront and demo those to us? And then, I ended up getting a job as a result. You have a couple of different options. You go to wavefront.com, you can schedule a demo with an SE like me, and we can really dig into the integrations and do things on a larger scale and talk about your specific items you'd want to address with Wavefront. But you can also just go ahead and sign up with a free trial. It's 30 days. You get, when you log into Wavefront, after you've signed up, your UI will look exactly like this. So I'm logged in as my own user account right now, but you'll be able to use all the existing dashboards. You'll be able to integrate by any of your implementations. So if you're looking at Linux, for example, you'll be able to do setup. It's literally a copy and paste. Anything you see in this UI is specific to your own Wavefront login. So if you're doing tooling or if you're using the command line or whatever to just get stood up on your Wavefront trial, whether you're talking about a host, you're talking about a container or an application, everything is already here. And also what'll happen when you sign up for trial is that we'll reach out to you and make sure that you're covered. And if you need help from an SE like me, I'm definitely always happy to help you out, help you with an integration, talk about dashboards, and make sure that you're situated. Licensing works in terms of ingested points per second. Does anyone have any other questions?
Alrighty. So just thanks to Nate, thanks to everyone for joining. Appreciate your participation, and we will send out the recording of this webinar to you tomorrow. So enjoy the rest of your days. Thank you.
Thanks, everyone.